Hello, so continuing on problems from weekly contest 333. The last problem, find the string with LCP. So LCP here basically stands for the longest common prefix. And so we get an LCP matrix, and that represents a string word of n lowercase English letters. So important here that we have lowercase. And LCPIJ, this cell basically represents the length of the longest common prefix between the substrings from I up to the end and from J up to the end, right? So let's say you have some I here, J here, then LCPIJ represents the length of the common prefix between this substring up to the end of the string and the substring from J up to the end of the string. So basically the common prefix between the two. And so we get that LCP matrix, right? And we want to return the alphabetically smallest string word that corresponds to this LCP. And if it's not possible, then we want to return an empty string. Okay, and smallest here, just smallest word, like it's both in terms of the length and in terms of the characters. Okay, so how do we solve this? So the main intuition to think about here is that we have only lowercase letters, right? Lowercase English letters. So that's one aspect. And so what we can think about is, let's just place from A to Z as long as we can, right? And of course, according to the rules in the LCP matrix. And so basically what we will do is, if we have an LCP at some position ij that is bigger than 0, what does this tells us, right? So this means basically that there is a common prefix of length bigger than 0, right? Such that basically the word from I to, let's call it string S, right? So from S to I to the end, and S from J to the end, there is a common prefix here of length 1, right? Of length bigger than 0. So what this tells us is the first letter has to be equal, because otherwise there is no common prefix, right? Common prefix means the first portion. So let's say this is S, let's say this is I, and this is J. If there is a common prefix of length bigger than 0, that means these two positions are equal, right? And so if this is the case, then this means basically that S of I needs to be equal to S of J. Okay? However, and no matter what the value here, if it's 1, that means only the first letters are equal. If it's 2, that means the first letters and the next ones are equal. If it's 3, that means the first letters, the second and the third are equal. But as long as it's bigger than 0, the first letters has to be equal. Okay, so that's one observation. Now, what about if it's equal to 0? Now, if the LCP at ij is equal to 0, then that means there is no common prefix between the two, right? So let's say I here and J here, right? So if the LCP tells us this is 0, that means there is no common prefix. That means the letters here are different, because if they were equal, let's say A here and at G there was A, then there is a common prefix of length at least 1. But if it's equal to 0, that means we have to have different letters here. So that means it's different. Okay? So what we can do basically in this is let's just use our LSP to construct a string S, right? And then once we using basically, because we want the smallest lexicographical substring, it's always better for the first letter to be the smallest possible one, and for the second to be the next smallest one. So if here we are told that at this position it has to be different than A, right, because they don't share a common prefix, then let's aim to do the next smallest. If for example 0, 1, 2, if the LCP of 0 and 2 is equal to 0, right? That means this here needs to be different than A, okay? And so what if LCP of 0 and 1 is also equal to 0? That means this letter here needs to be different than this B. And so we have to do a different one than both A and B, so we put C. So basically we put the next character. So our characters will go from A all the way to Z, right? But if we get to a position where we want it to be different than all of these, right? But all of these are taken, then it's not possible, so we just want to return empty string, right? And so that's roughly how we are going to do it. Now let's apply it to an example before doing that. Before doing that, actually, let me just finish the structure here. So we will just fill a string S, right, according to the rules of LSP, and try to make it as small as possible lexicographically. We'll just follow the character orders. And once we fill it and we have a candidate string, we just want to make sure that there is no contradiction. So once we fill our entire string S using the rows of LSP and the fact that we want the smallest string, so we follow the alphabet order. Once we get that, we want to validate that that string actually works for all the LSP values. And so to do that, we will just make sure it follows the following rules. So basically, if S of I is equal to S of J, right? So that means, for example, AB, 0, 1, 2, 3. So the character here is equal to the character here. S of 0 is equal to S of 2. So if this is the case, we need that means there is a common prefix between this here and this here, right? So that means basically that the LSP of 0 and 2, because they are equal, right, it needs to be length 1 plus the length of the rest of the prefix, so of the common prefix between the remaining part of each one of them. What is the remaining part of each one of them? Is just LSP of 1 and 3, right? So LSP of 1 and 3, LSP of this portion and of this portion, right? And so if we generalize this is actually generalizable, is that if this is equal, then we need the LSP of ij needs to be equal to 1 plus the LSP of the next common prefix, right? So let's say you have, let me just clarify this even more. So 0, 1, 2, 3. So these are equal. And so the prefix LSP of 0, 2, right, needs to be equal to the 1 plus the LSP of the remaining portion of each, right? That's the idea here. And so that's what we are going to write here. So this is going to be, let's just remove this first. It's going to be LSP of I plus 1, j plus 1. But if this is not the case, that means our string violates one of the LSP values. And so we want to, that means the string here is not valid. And so we just want to return empty, because it's valid according to some of the LSP values, but not the others. So we want to, so it's not possible. So we want to return empty string. Now, what if they are different? So this basically means that S of I is different than S of J. So in this case, that means that the prefix has to be 0. The LSP value of ij has to be equal to 0, because this means that from here, I, j are different. So that means that these substrings have no common prefix, because the first letter of each one of them is different. Okay? But if the LSP value tells us something different, so if the LCP of ij is different than 0, that means this is not valid, so we want to return an empty string. Okay? So this is basically the validation that we can do, and we can do it for all I and j, right? So we can do it for all I and j, right? Okay? One other use case that we can handle differently is the edges of our LSP matrix. So let's say we have our LSP matrix like this, right? For this one and this portion, right? Because there is no I plus 1, j plus 1, we want to handle it differently. So what do we need to do for this case here? So for this case, so this n minus 1 and this is n minus 1. So the LSP of I n minus 1, right? If this is bigger than 0, right, it needs to be 1, right? So this would be equal to 1 if S of I is equal to S of I minus 1. Okay? And so basically, if this is bigger than 0, it needs to be equal to this. So and it's not valid if, let's say if this is equal to 0, then this has to be different than 0. So if we ever have the values of these two different, right? That means if this is different than this, that means either LSP here was 0 and this one was true, so it was 1, and so they are different, or this one was 1, and these were different, so the value was 0, and so they are different, then there is a problem, right? And so we want to, if ever they are different, they need to be always equal, because if this is 1, that means these two needs to be equal. If this is 0, that means these two needs to be different, so it needs to be 0. But if they are different, that means it's not valid, so we want to return an empty string. Right? And the same thing applies to this case here, right? Just by symmetry, we just say LSP of n minus 1 of I, if ever this is different than the SI equal to S of j, that means the same thing. That means basically that this has a common prefix of 1, but these two have 0. They are not equal, so that's not valid. Or this is 0 and these two are 1 because this is true, but here it tells us there is no common prefix, so it's not valid, so we want to return an empty string. Yeah, so that's pretty much the idea here, is that we use our LSCP first to construct a string, but by trying to, each time we place the smallest character we can place, and then once we do that, we just verify that the LCP, all the values of LCP, apply correctly to the string. If we find any contradiction in our validation, we return an empty string, and that's pretty much it. So yeah, let's implement this solution. Okay, so let's write what we just saw in the overview. So what we need first is we need just the length of our LCP. And then we need a string, right? The candidate string that we want to fill. So initially it's all empty characters. And then what we need to do is so this is just for the number of characters we need. And then we need to start our C from A, because these are lowercase letters. C will go from A all the way to Z, right? And now we'll just go through all the LCP values, so both I and j up to n. And first we will see if we already placed a value in this position, right? We already placed a character, we just need to continue. We shouldn't place a new one, so we just continue, go to the next index. Otherwise, we want to add the smallest possible character that we can add, and the answer is C, because the other ones we already placed and we already used it. If we use them, we would have a common prefix when we shouldn't, right? And so that's why we do it like it. So here it's actually, if it's different, which means we already placed a character. Now if C is bigger or equal to, is bigger than Z, that means we already placed all the possible lowercase characters. So we have more possibilities than the number of lowercase characters, so this is not valid, so we want to return an empty string. And then, well, after that, here we check if the LCP of ij is bigger than 0. That means there is a common prefix, right, between s of I and s of j up to the end. So that means there is a common prefix. of these that is bigger than 1, that has a length bigger than 1, right? So what should we do here? So with this, then what we need to do is, that means that s of I, the first letter of this substring and of this substring are equal. So that means basically that the s of I is equal to s of j. So we just assign to s of j, we assign the value of s of I, because we already filled s of I, right? We could also, if you want, do the same thing we did here, which is if we already filled s of j, just skip it, right? Just continue. Okay, but we will do the validation anyway later on, so you could also remove this. Okay, so once we do that, we placed a character. So for the next iteration, we don't want to place the same character because that means there is the same prefix, right? And so what we do, let's actually remove this. So what we need to do is just increase C to the next character. So how do we do that? Well, we just convert it first to a number. We add 1 and then we convert it back to a character. And this will give us the next character. And now we will have a valid candidate string. So let's just actually print it so I can show you. Join, and let's return that string. For now, it's in some cases it would be wrong because we didn't do the validation yet. But let's okay, so now we need to do the validation. So this here basically is build S. This portion here is to build S. And then here we validate it. Okay, so the first part is we want to validate against the last column in the last row. And so for that, we just check if LCP of I and n minus 1, right? If this is different than s of I equal to s of n minus 1, so basically this means that either the characters at I and n minus 1 were equal, but the LCP was equal to 0. So there's a contradiction here, because if they are equal, then the common prefix needs to have length 1, right? Or the reverse. So if any of these are different, that means we have an invalid string S here. And similarly for n minus 1 I, right? So we do it for the last column in the last row. So let's just do that like this. So that would be just here n minus 1 and here for I. Okay, so once we do that, we validate it for the last column. So validate last column and last row. Okay, and now here we validate the rest of LCP. Why did we do this one separately? Because for this validation, we need to validate that the LCP of IJ, right? If these are equal, right, we want to validate that this is equal to 1 plus LCP of I plus 1, J plus 1, right? And so this here, it would not be valid for the last column and the last row, okay? So that's why we are doing it. So here we are going to say up to n minus 1 because we already handled n minus 1 here. So we just up to n minus 1, so that in Python it stops at n minus 2. And similarly for J, right, the same case. And so here we do exactly this. If they are equal, right, then if this is not valid, right, so if these that are equal, that means that the length of the common prefix between the two substring is 1 from the two first characters that are equal plus the remaining, right? So which is this. But if that's not the case, then we have a problem. And so we want to, if this is different, then the string is not valid, so we want to return empty string. Okay? Now otherwise, okay, which means basically the character at I and J are different, right? So in this case, we need the LCP to be equal to 0. Because they are different, that means there is no common prefix. But if that's not the case, then that means there is a contradiction and we need to return 0. So this is the validation we want to do. So if this is different than 0, that means it's not valid. We want to return an empty string. And that should be it, pretty much. So let's run this. I'll submit. And that passes our test cases, okay? Now, in terms of time complexity here, we are doing O(n) here and O(n) here, so O(n) squared. Here we are doing O(n). And here we are doing also O(n) squared, right? So overall time at upper limit is O(n) squared time, right? In terms of space, we are using the character itself of length n. And that's pretty much it. We are using the original LCP, so we have O(n) space. Yeah, so that's pretty much it for this problem. Please like and subscribe, and see you on the next one. Bye.